I mean, just like abandon the notion that there is like a path to to data science. That it's just, I think experience has shown that's just not true. People get in via many routes and then do many things subsequently. So just forget about it.
Hello everyone, Ken here, back with another interview for you. Today, I had the pleasure of speaking with Jeff Charbeneau. Jeff is a friend of mine from Chicago who works on the machine learning engineer side of data science. He's probably one of the most passionate people I know about machine learning pipelines and ML ops. Jeff's road to the present began in statistics. After several years in academia, first as a biostats graduate student, then as a staff biostatistician, he left to do quantitative things at a now defunct intellectual property startup. Next came data science consulting using crowdsourcing, which he generally doesn't recommend. He thinks that things officially started to get interesting when he started working with software engineering teams. Over time, he developed a passion for building things that work and also automating them. He came to view well-engineered infrastructure often as needing to precede higher-level efforts like data science, machine learning, and so-called artificial intelligence. He's a big fan of Prefect, and he thinks it's incredibly interesting. He's compared it to Airflow in an article below here. When not working, Jeff enjoys spending time with his wife and 2 kids, working out and cooking. Now, on to our interview.
Awesome, Jeff. Thank you so much for coming in. To everyone watching, Jeff is a friend of mine from Chicago. So he works in a data science, but more focusing on machine learning engineering type role. So I think he would be a really good person to bring in to talk with, because he can talk a little bit more about what a machine learning engineer does, where that career path is going, and what that might look like in the future. And that's going to shed a lot more light than I personally can. So Jeff, thank you so much for coming on.
Yeah, absolutely. Good to be here.
Yeah, great. So I'd like to start out just going a little bit about your background. So the first question I always like to ask is, how did you get into the data science machine learning space? Like, when did you first realize that this was appealing to you?
Yeah. So I entered via academic statistics. Step 0 for me was graduate education in biostatistics at the University of Michigan, where I did a terminal master's degree. And then step 1 was statistical consulting as a biostatistician at the University of Chicago and University of Illinois Chicago, or UIC, helping physicians and scientists and physician scientists, so MDs, PhDs, and MD PhDs, write manuscripts for publication, analyzing data for them, putting together study designs, putting together grant proposals. But it was statistical consulting. Did that for 5.5, 6-ish years. I sensed that academia was not going to be where I wanted to be forever, and kind of got bit by the startup entrepreneurship bug along the way. And
I think I've been bit by that one a couple times. So
yeah. And I left academia for a startup in, of all things, incredibly intellectual property. And the firm no longer exists. It was called IPXI. They were trying to make an exchange and marketplace for tradable portfolios of patents. And you might wonder, what in the hell was somebody with statistical training and data analytical skills doing there? And looking back, I kind of asked myself that, but it seemed like a good idea at the time. So I went in and thought I was going to help them try to predict which patents were going to be good before I even knew what that even meant. And then worked to develop, quantitative tools to group patents that were related to each other in a certain way, just using somebody else's metric. Did some hierarchical clustering, because they would get these huge patent dumps of like 200 patents. They wouldn't know like what related to what, and then kind of speed up the due diligence process. And then went on to put together a simulation based way to price what we were trying to sell. I stayed there too long, probably about 1.5 years too long, but whatever. And then got into the thing called data science at a Perio top coder. So top coder was Kaggle before Kaggle was Kaggle. I think they started off in trying to speed up algorithms and then got into data science competitions, and they're using crowdsourcing, crowdsourcing to do the work essentially. And worked there about 6 months or so before I realized that is probably not the best way to build things with data, and started to look around for other opportunities, and went in-house at Salvo Group as it was a B2B software as a service firm here in Chicago, as a member of a development team trying to add more like this features to their product. So they were in what's known as a sales enablement space. They were very much about findability, and their software users, the user story, if you will, was, okay, I'm looking at a piece of information in my company's catalog of information that I can use to talk about the things that we have to sell. And I want to see more things, more assets, more documents, more PowerPoint decks that are like the one I'm looking at on the screen. So it's kind of search and NLP and findability related, and we made something work, but it wasn't great, and the product never made it out of beta. And then I got repurposed to do just general work on search, and what does it mean for search to be good? And to my great surprise, a company that was in the findability space hadn't really systematically tried to measure their search result relevance, like at all. And just Googling around a bit, found some standard metrics and began to apply them systematically to their search results and kind of help them see a way forward. I figured out that there was probably not that much data science to be done at Salvo, and I left to join my current group at US Foods. There's a small corner of US Foods called Food Genius, which is a former startup US Foods bought in 2016. I came in May of 2017 to do data science stuff initially. I knew the guy that was the executive director of the place. We worked together at a period top coder. He said, come quick, come quick. We have need of the data science. And I said, sounds great. So initially it was POCs around product recommendation using initially like matrix factorization and hybrid matrix factorization techniques. The package is one made by a guy who's now at Netflix, I think. But at the time, he was at a company called Lyst, L-Y-S-T. I don't know him, but he's really good, and I believe his first name is Macy. I'm probably butchering the pronunciation. The package is called Light FM, and that's what I used on that POC. And then there was another POC involving integer programming for SKU rationalization. US Foods has too many of the same thing in inventory. By way of example, at the time of this project, there were 58 different varieties of chicken tenders in the Chicago distribution center warehouse alone. Seems like too many.
A lot.
So you could get rid of some of them, but which ones do you want to get rid of and why? And that POC was around that. And then things got interesting because we finally figured out what we were supposed to build and do at Food Genius for US Foods, and that was to create a data ingestion and transformation pipeline that solved the following problem. And the problem is, as a US Foods sales rep, because I've got so many accounts and I'm terribly busy, I couldn't possibly know what all of my customers who are, bars, restaurants, hospitals, anywhere people eat food, what all of those places have on their menu, and what I'm not selling them that's on their menu, right? So it's new opportunities at existing accounts. Super simple to describe at a high level. Turns out not to be that easy to do when you're doing it at the scale of 50, 60,000 independently owned and operated restaurants, and you have to find their homepage and then crawl the website and figure out how to intelligently find what you're looking for. So I was repurposed as more of a general back-end engineer doing something like data engineering meets DevOps fairly early on in my tenure at US Foods, and learned a ton. Concretely, GitHub for all the things. We put all the things in Docker containers. Wrote a fairly straightforward Python package to help orchestrate this pipeline, and then figured out how to scale horizontally using an AWS service called Fargate, Elastic Container Service. It's just a way to run Docker containers and not permanently. It's kind of on demand, right? They're ephemeral.
Would Kubernetes kind of fall into that same type of infrastructure?
Exactly. Yeah, it's similar. So I am not a Kubernetes. I've done some Hello Worlds on my local in Kubernetes, so I really don't know whereof I speak, but it's in the same family. Yeah, Kubernetes is a container orchestrator. It coordinates containers that make up applications, but that are separate from each other and don't really know about anything that's outside of their container. And ECS is composed of, there's just a single container, I'm pretty sure. So we figured out how to scale using ECS, Fargate, and that's a variety of Elastic Container Service, and Kafka, which is a messaging framework. And it was unreasonably effective with.
That's good.
Yeah, with 4 people, myself included, we did a lot of really good work and brought a lot of value to US Foods, building what was in essence a search engine times a web crawler on steroids. It was really, really cool. And super simple if you just back up and look at it the right way.
Well, that's what it all should be, right? It should appear very simple to the outside looking in, and we all know that it's blood, sweat, and tears inside. Well, there's a couple of things I'd really like to highlight for the audience about your background. The first thing is you went into a bunch of different, went down a bunch of different paths, right? You were in the consulting, in academia, you went through a couple of these different companies, and it seemed like in each of these different places you picked up a couple different skills, and that made you more marketable as you went. I mean, in some of them you didn't have the title of a data scientist, right? But you were still learning those skills and you were still progressing them forward, and it was still making you into the data scientist, machine learning engineer that you are today. I think a lot of people get really wrapped up in, one, being called a data scientist, and 2, that that they're never going to make it into the data science career path. And you can be doing data science work, and a couple of things, your age, your experience level, a lot of these things don't necessarily dictate the type of work you're doing. It might be a somewhat personal question. You don't have to answer this one. I can edit it out if you want. But do you want to ask, at what age you were roughly when you landed your first, what we would call a true data science role?
I didn't have, so I was data science manager at a Apereo top coder, and the year was 5. When did I start there? I think I started in 14 or so. That's how many years ago? 6 years.
6 years, yeah.
Yeah.
You don't have to say it.
Yeah. No. So I was in my 30s.
Well, so I mean, that to me, I get questions once a week at least about, hey, Ken, I'm 25 and I'm starting to learn data science now. Is it too late for me? Or I'm 28 or I'm 29.
Utter nonsense. Yeah.
Exactly.
You can, if you're inclined and can find the right reading list or tutorial or program
or YouTube channel, you never know.
Or YouTube, by way of example, you can do it. It's not. I think tech is pretty much a meritocracy. If you can either do it or you can't, and there are a lot of ways to come to be somebody who can do it.
I agree 100%. It's the great tech, in some ways, is the great equalizer.
Yeah.
So you coming from a more pure statistics background, I'd love to understand how you learned, or the biostats background, how you picked up on all of the programming. You know, what
Yeah,
was your approach for learning that? How did that take place?
on the fly. I mean, it really didn't begin to happen until I took the job at IPXI, and I realized I was in over my head trying to do what I was trying to do and process a bunch of unstructured patent data. And I thought that Python was probably the thing. I only knew R going into it. Python would probably be better for that at that time. And I got a tutor to help, give me a crash course in Python and how I could do the sort of things that I'm trying to do now in this language that I barely know. I never had any formal instruction. I might have taken myself through Learn Python the Hard Way, which is a really good resource. But that was really about it. And then everything since then has been just learning on the fly, learning from colleagues and coworkers, reading. I had one course by, what is his name? Dave Beasley. He's a Chicago guy, huge in the Python community. Up in Andersonville for a couple of days, really good course, super intense, but you'll learn a ton. And that's it. That's really the only formal Python instruction I've had. And that's just like one of the things that I've had to learn along the way. And I would say that, like, if you want to be successful in data science or in particular tech in general, being able to figure it out, right? Like, know how to Google things. I'm not kidding. Like, know how to Google things, know how to find an example that's almost exactly what you're trying to do that works, and then repurpose it to meet your needs. Learn how to read documentation. Sounds pretty simple, but it's often not easy.
Yeah. Well, I love that. That's almost exactly how I recommend learning programming, learning data science, all through project, all through real experience. I mean, one thing you said was on the fly, right? And that means as you're going, when you run into the specific problem that you have, you go out and try and find the solution.
Yep.
I think so many people get into this mode where they're like, oh, I need to learn the whole language.
No.
I need to learn everything before I start on a project. And if you do that, even the person who created Python probably still has to look up some stuff every now and then, because if I wrote a book, there are things that I don't remember about the book, I'm sure, right?
Yeah.
And so it's like, well, when you're going about it that way, instead of it being this gigantic corpus of knowledge you have to learn, in the moment, you only have to know that one specific solution or work on that one specific problem. And so I really like that. The tutor approach is not something that I've heard before, and I really love that. I think that not enough people realize that there are a ton of different resources out there to learn these things, and you have to find the one that resonates best with you.
This was a guy, he was just a software developer who knew Python. It's like, hey, I'm in trouble. I need help. help me climb up the learning curve faster than I would on my own. So,
and how did you find that person? Was it on like Craigslist or someone in your office?
Something like that. Yeah. No, it was somebody I sought out on my own, and hourly, and we met a couple times over 6 or 8 weeks or so, and then it kind of reached its logical conclusion. So,
well, I cannot stress enough how much I like that. Is that it's also that you're not looking for just like a data science tutor. You're looking for someone, okay, I want to learn the Python concepts. I can go to a Python specific person, where there's a lot more people that know programming than know data science. You don't have to just go to one person for all these resources. A lot of people are like, Ken, will you mentor me in data science? And I'm like, I don't have time for that one. But you can find 4 or 5 different people.
Yeah.
One can teach you the statistics, one can teach you some of the programming elements, one can teach you some of the business knowledge that you need, and maybe one can teach you how some of the infrastructures work that are relevant, or how to actually create a really cool visual or something like that.
Yeah.
You don't have to just go to one resource for everything, which is something I really always try to stress.
Yeah. I think one of the things I'm decent at is like finding the good people and then copying them. That's it. Just you, it shouldn't be that hard to figure out who the good people are and fill in the blank subfield, right? Find them and copy them. Read their papers and find their patterns and do what they do because they're better than you.
Yeah, well, there's a lot of good resources to do that now. You can go on Kaggle, right? And I can say, okay, these are the 4 guys who have won the 4 most recent Kaggle competitions. I can look through all of their notebooks. I can see the approaches that they took, and that's free. That's something that, you know, probably one of the best ways to learn is just reviewing other people's code, because
Yep.
that's a look into how their brain works, right? That's a look into their thought process and going all the way through.
Yeah.
So, you know, that and GitHub, you said you were going through a lot of repos, going through the documentation. That's how the person that created the package's brain works.
Mm-hmm.
So I absolutely love that. I think there's so much good stuff that people can take from your learning process and how you've accumulated that knowledge.
Yeah. I would also encourage people who might even have an inkling of doing more engineering type things, like I've done over time, to get an AWS account immediately and start building stuff that works, that runs end to end, that somebody else can take and run on their machine. It sounds easy to do, and it's just not. There's a lot that goes into it, and one of the reasons I like the more engineering aspects of this rarefied profession is that the problem set becomes bigger, and there are more dimensions to consider when you've got to fit your model into a system, or you've got to have this thing that talks to that thing, right? The problems get really, really cool and in a hurry, and the work gets extremely challenging. So anybody who's got an inkling of engineering interest, get an AWS account and find how to start doing stuff. I think you'll get really into it pretty fast, and I think you'll make yourself more valuable.
I could not agree more. I think one thing I always recommend with people in their project portfolio is try to at least do one end-to-end project. Make some sort of product, because, like you said, with products come a lot more problems, but a lot more opportunities.
Yeah.
If you have something that not something that someone can hold in their hand, but something someone can play with is very different than a recommendation or something along those lines. And I think you'll be really surprised at how much opportunity comes from those things, because products are a lot more shareable than ideas.
Yeah. Yeah. It helps you figure out what you like to do. It gives you things to send people, after interviews. It gives you things to talk about in your job search. It's you get a lot from it.
Awesome. Well, that was honestly a really good segue into the other broader topic that I wanted to cover, which was data science versus machine learning engineering, kind of what those are and the direction you see more machine learning engineering going. I've talked quite a bit about where I see the data science field in general going, but you touched on a little bit more on the product side, but how would you differentiate data science, pure data science skill set versus a machine learning engineer skill set?
Yeah, it's a good question. Somebody else asked me this today. I would say data scientists have been, for a bit now, more focused on analysis and answering business questions, and along the way, covering more business questions to answer, because that always happens. That's like one bucket. And then another bucket would be, most people are more interested, I think, in supervised learning, and predicting something than just grouping things or creating clusters. So creating a model that predicts a thing, right? sometimes you want to get into inference and test like relative effects and things like that. But I think those two buckets are where most of the focus has been. I would say with machine learning, you're taking a thing that was made to predict, to predict, and fitting it into a system to where it does predict, and being able to do that and monitor the performance over time and retrain the model as needed in as much of an automated fashion as possible. That makes sense?
I think it does a lot. In like very, very dumbed down terms, it's kind of like data science are more part of the discovery process, and they do have some solutions, but machine learning engineers focus more on pure implementation,
Yeah,
and getting true value out of the models that they either make or that data scientists have passed off to them.
yep, yeah. I would say that's fair. Like concretely, one of the things that I worked on after that crazy web crawler search engine was a classifier that given a web page, is it a menu or is it not? Because we're really only interested in menus, right? And so we called this thing menu vision initially because we had a bunch of screenshots of web pages lying around, and a former colleague said, I made a classifier at my last job that classified documents, binary classifier based on images. I think we could probably do it here, like go nuts. So he sketched something out and it looked like it might be working, pretty simple 3-layered CNN. And then he left and I picked up his work and like, this is really complicated. So I simplified it and I just couldn't get it to perform better than just calling everything a menu because of the class imbalance, right?
Yeah.
Most things were not menus. Only about 15 to 20% of pages that we ended up finding on websites were menus or menu-y, enough for us to want to pay attention to them. So it's like, well, what are we gonna do now? Well, this is no good. What else we got? Well, we got a bunch of URLs. And if you tokenize a URL the right way, you can recover a lot of information about how menu-y it is. Yeah, you don't split on white space because there ain't no white space, or if there is, you don't want to split on it. You split on forward slashes and periods and things like that, and you surface and call them embedded tokens. A lot of PDFs are gold for Food Genius, and they're using menus. So anything ending .pdf, that's probably a menu. And anything with menu as like an infix, like spring menu v2, written as one word, that's a menu. But you've got to look for like the menu substring the right way. But if you do that and then just minimal TF IDF feature creation, I got a really highly performing classifier and with minimal model searching.
See, typical data scientist, I would have over-engineered. I was like, oh, like he already had an existing one. We could use some transfer learning and train it on every type of website, and then just cut the last couple layers off. And that's probably not the optimal solution. I love that.
Yeah. Well, to be fair, I wasn't coming in with this model, but yeah, I mean, I tried all the fancy stuff and it didn't work. And it was like, all right, what else we got? What's the simplest thing we could do? I think it was a linear kernel support vector machine on TF-IDF space that was really, really performant. And then getting to the machine learning engineering part, figuring out how to like get that somewhere where the other parts of the system could use it. And I figured out how to get it into a Lambda function using Lambda layers so that there's not a server always up and running. And you can call it, essentially on demand, and it can scale elastically and then go away.
And so what tools would you say you're using on a regular basis? Obviously AWS, but are you using SageMaker? You mentioned the Lambda functions.
Yeah, I've used SageMaker a little bit. The notebook instances I think are really good for portability. By that I mean it it works on Joe's machine, it works on Bob's machine because it's all the same machine, right? They're just taking turns on the same notebook instance. But and under the hood, that's really a Docker container. So I think I would strongly encourage data scientists to learn enough about Docker in order to work in containers, because that will give people trying to integrate their models into systems a huge head start. It makes your work portable. If you can figure out how to do that, you've solved a lot of the headache. So I would say GitHub, Docker, and then for AWS, I really like this thing called CloudFormation, which is a way of creating AWS resources that work together and what's known as a CloudFormation stack. And you define it as a YAML template and specify, all right, I want this S3 bucket and call it this and give it these permissions. And then I need this trigger that talks to this Lambda function when a new thing lands in the S3 bucket, and that is going to kick off something else downstream. But yeah, I think containers for most data scientists would probably be a huge value add, and I'm trying to cram them down the throat of everybody I can at work and having some success. So,
well, a lot of people don't realize this when they're starting out, is that data scientists in most companies and in the future are going to have to work very closely with software engineers, with machine learning engineers, with anyone. And you want, as a data scientist, you want your work to be useful. Mm-hmm. And your work is not useful if no one else can pick it up and use it very easily. And things like Docker, something as simple as a requirements.txt file in your GitHub repo, they make it so that other people can reproduce your work, other people can spin your things up relatively easily. And if you can do that, that's a huge feather in your cap for anywhere you want to work, because they know that you're going to play well with others, you know, as funny as that seems.
No, it's absolutely true. I mean, we not too long ago hired a computer vision consultancy because we didn't really have that much in-house CV expertise and didn't have bandwidth to do the sort of stuff that we were wanting done, and had a POC and, you know, paid a non-trivial amount of money for it. And it looked like it was kind of, you know, promising, but I couldn't ever get it to run on my machine because it wasn't in Docker. I was like, wait a minute, we just paid all this money and
only they can run it.
Well, it's not that only they could run it. It's just, it was not portable, right? It just wasn't portable because I failed to add that in as a project requirement, right? So lesson learned. And subsequently, we had like a follow-on effort. All right, well, now let's Dockerize it. And then we got a hard asset. Then we got a Dockerized framework that we can use to draw boxes around interesting parts of images, which is really useful if you're trying to do this weird thing of cut up menus in the right way. So,
well, one thing you said there I think is really important. You said requirements. Mm-hmm. And we've talked quite a bit in the past about DevOps. We've talked a bit about in the past about how data science machine learning fits into the bigger infrastructure. Would you be able, for the people watching, to help define DevOps for them, especially as it relates to data science and machine learning?
Yeah.
I asked you because I have trouble defining it. So
yeah, I mean, it's a tough thing. I would say let's talk. I think it might be easier to say that, well, what one in DevOps does, and one in DevOps creates methods of automatically building, testing, and deploying software in as automated fashion as possible. So you click a button and the Docker container builds on the build server, and then all the unit tests pass or fail, and then the integration tests pass or fail, and then it's promoted to an environment where people make sure, you know, they're happy with the results. Building pipelines, working on orchestration of different resources, figuring out how to make things talk to each other. It's about coordination of infrastructure and resources and automation.
That was a very good description. I was going to echo that when we talk about data science, I think DevOps is generally where we hear pipelines the most. That's, in software engineering, we call it something else, but in data science, whenever we're trying to create a system, we're talking about pipelines. And, one of the most important thing about pipelines in general is their robustness, right? So we can deal with whatever data is coming in and it's not going to break, right? Yep. Which for me is almost one of the most challenging things, especially when you're creating an API endpoint, when you're creating something that someone else is going to use. Mm-hmm. The whole idea of a RESTful API is that when people send it something, they should get a reliable response.
Yep.
And even if they send it,
or an error that's expected, right? Exactly. It's like you gave me the wrong input. Try again. Yeah.
In anything we do that's remotely technical, we never want to have errors or bugs that we can't explain, especially in production. So I would say that at a high level, some of this stuff is about consistency and creating things that, again, are products. Like if you buy a hammer, you want to be able to bang it on something all the time without it breaking routinely. And it's the same thing. We want our models, you want to be able to bang them on the table, run them through a bunch of stuff, and for them to still produce really good results.
Yeah, absolutely.
One of we're kind of coming to the end here, but I have 2 or 3 more questions. Yeah. The first is, where do you kind of see the machine learning engineer DevOps position going? I talk quite a bit about, in my videos, I see the broader field of data science splitting a little bit. One is moving more towards consulting. So data scientists are helping, they're doing some model building, but they're doing a lot more explaining what these things do to the business stakeholders. Yeah. And the other side is almost completely the opposite direction, where it's all implementation. It's more close to software engineering, where they're really building robust infrastructure around the tools that they're making. We've also talked a little bit about AutoML, and that means that, with that software engineering side, a lot of some of the grunt work, some of the tuning can be automated away in the future. Is that in line with sort of what you see? Is there any additional, if that is kind of in a similar light, is there any additional nuance that you might kind of want to expand on there?
No, I mean, that's essentially my view. There's, analysis and helping people understand what's going on and make connections and answer questions and create new questions in the process of answering those questions. I think there's, the engineering aspects that are never going to go away. These systems don't create themselves. Software ain't going to write itself anytime soon. And then another one that's, I guess it's certainly heavy engineering, and it's still kind of like what I think data science used to be, where you're just you're really focused on fitting the best model, is the super complicated deep learning architectures with the huge models and the new techniques. I think that there's going to be work remaining in that field as things get bigger and bigger and more complicated and deeper, or there are hardware breakthroughs, and now we've got a new toy to play with, and what does that do to the network architecture that we can use, and figuring out how to advance the field on the cutting edge of methodologies. So, I mean, that's kind of engineering, but
let's call that research, right? I mean, that's
research. Yeah.
I like that. That's 100% something that I think I've left out. I mean, I had a really good talk a while ago with Anima Nankumar. So she's one of the directors of, I think the director of AI over at NVIDIA. And I had this whole conversation with her, and I leave that part out of my future of the field analysis, right? No, but I 100% agree. There's, again, the people over at NVIDIA are doing some pretty incredible stuff.
Oh yeah, it's amazing, and it's deeply interesting to some people. It's just I like the engineering stuff. It's like I've looked at those jobs and it's like, this is fascinating, and I don't want to do it. If that makes any sense.
Well, you know, it's funny you say that because I fall a lot more on the storytelling side, right? I like being able to weave this narrative to make people understand why decisions are important based on the data, based on what the models are saying. And it really does show that there is room for people with different preferences around either the hardcore implementation, the storytelling, or the really deep research within the broader umbrella of data science within the field. So, you know, for anyone watching, again, if you lean one in particular way, like that's totally okay, right? I mean, you don't have to view it how I view it. You don't have to like the same things Jeff does. You don't have to like the same things Anima does.
Oh God, no. And, yeah. I mean, just like abandon the notion that there is like a path to data science. That it's just, I think experience has shown that's just not true. people get in via many routes and then do many things subsequently. So just forget about it.
You just nailed the teaser for the video, so thank you. That was perfect.
Cool.
I love that. Last thing is, if there's anything you'd like to share, any final advice you have for people either interested in breaking into the field, related to machine learning, engineering, the floor is really yours to, you know, you can talk about your favorite charity, whatever, and anything is up for grabs in the last little bit.
All right. So I recently learned of a very cool, let's call it job running framework. You could use it for ETL things. You could use it for cron jobs, and any job that unfolds like a directed acyclical graph or a DAG could be done in this framework, in this tool. It's called Prefect, Prefect. Prefect. Yeah.
And does that work on not Mac? Because I've worked with Airflow. I assume that does something fairly similar. But it only works on Mac.
It's so Airflow. This is, I think, the natural successor to Airflow, and I'm still new to it. It was created by an Airflow engineer, and it solves one of the major pain points that I experienced when the first time I used Airflow, and that was getting results or data or objects from one step in a job, in a DAG, to the next step. That sounds trivial, right? It's like the output of one function passes into the next function. And it's just not, because of the way Airflow has been built. And Prefect makes it really simple. It's as simple as it sounds. And they've done a nice job of solving that problem. And they've separated things where you can offload all the back end scheduling and logging of what happened at every attempt you tried to run a DAG to them. They've got a cloud offering that's really cheap to get in, and then you can run these jobs anywhere. You can run them on your local machine. You can run them on an on-prem server. You can run them on an EC2 instance in AWS. You can run them in Fargate. All you need is a token from the server that can be authenticated, and it's I think a really good tool that's going to go places, and I'm trying to find a way to implement it at my job. So
I love that. Well, you know, one thing I will say for anyone who's trying to land a job, if you're using some of the more advanced frameworks, if you're working with pipeline tools that are fairly cutting edge, when you're being interviewed, people will kind of just assume you can use the other ones, right? If you can use Prefect, someone would assume generally that, oh, if he can do this, they can probably at least conceptualize what Airflow is pretty easily. You usually have to use containers with these things. They probably at least have an understanding of how Docker works, and it works all the way back. Yeah. So you don't have to know all the cutting edge tools, but if you do, you can kind of, you know, you see that job posting with 40 different technical tools on it, and you can say, oh, I know the most advanced one. they'll probably work their way back and see
Right.
and at least assume that I have some understanding of these other ones. So I love that. That's a great way to end. No one has ended with a cool technical tool, a fun kind of a hot topic like that. So
furthermore, I've got a publicly available repo that compares the same job for Prefect and Airflow.
I'll link it in the description. How about that?
Yeah.
Perfect. Great stuff. Well, thank you, Jeff. I really enjoyed this. I think everyone watching will get quite a lot of value, especially when understanding DevOps and machine learning engineering.
Great. Enjoyed it.
Awesome.